This is page 2 of notes in our Unit 7 practice, or our Unit 7 note packet, which is similarity, percentages, and scientific notation. So number 1, this is just me giving you an explanation as to why all the answers are what they are. So number 1 says, a car traveled 882 miles on 36 gallons of gas. How many miles per gallon did the car go? So notice how miles is written first. So when you're writing this as a proportion or ratio, as a ratio, you put the M first for miles, gallon would go second. So I'm just using M and G. So when I change this to a fraction, I want to put the miles value on top over the gallon amount. So I have traveled 882 miles over 36 gallons. So since my answer is not written as a ratio, we're just going to do 882 divided by gallons, and this is how many miles per gallon your car got. So 24.5, which is option J. Whenever you're working on problems like this, it's just important to stay organized. This is a very useful problem, so whenever, most of you are driving, so miles per gallon is important to know, especially when you're buying a car. All right, the next one says, what is the ratio of the area of a circle with radius r to the circumference of a circle with radius r? Notice how area is written first, so we're going to put area first, circumference second. So the area formula is pi r squared. The circumference formula is 2 pi r. But in this case, the radius is 2r. So we're going to actually replace the pi r, the 2 pi radius, with 2r. And now we're going to simplify. So this becomes pi r squared equals 2 times 2 is 4 pi r. To help us simplify this, I'm going to make this a fraction. So this becomes pi r squared. Oh, sorry, and I'm changing my colon piece to equals, which I should not have done. Sorry about that. So I'm going to change this to a fraction, and we're going to simplify. Notice how pi is written in the top and the bottom, which means it cancels. And also you're left with, so r squared over 4r. You have an r in the top and the bottom, which means the r in the denominator is going to cancel one of the r's that you have up top. So this now becomes r over 4. And when we rewrite that, we want to make sure that we keep the numerator as the first part, so r, and then the denominator as the second part of the ratio, which is 4. For a correct answer of option H. So in order to do this problem, you do need to know the area formula for a circle. And again, we're just pulling these problems where it says area has radius r, so we know that we can keep that r. And it also says that the circumference has 2r, so that's where this 2 radius comes from. Okay? And then always simplify using fractions. It's a little bit easier to kind of visualize. Number 3, Patterson Pond is stocked with 2,000 fish, all bass and trout. So there are only bass and trout in this fish pond. The ratio of bass to trout is 3:2. How many of each type are in the pond? So this is actually an extended ratio problem like we did on page 1. So you take your ratio, 3x plus 2x, and it has to equal the total of 2,000. So what I'm actually doing now is solving for that magic value that when I multiply it to my number of bass and trout, I will figure out how many total fish there are. So x is my 400. Bass is written first, and the bass is 3. So 3 is written first, so this would be 3 times 400 for 1,200. So there are 1,200 bass, okay? And we're looking for a trout. Trout is the second number, so 2 times 400 is 800. So there are 800 trout and 1,200 bass, which is option G. So remember, when you're finishing these problems and solving them, bass is written first, which means the 3 corresponds to bass. So when I'm solving, I'm going to plug that part in here. Okay. Trout is written second. The 2 is listed second, so when I'm substituting, I'm going to multiply my x value by 2. So pay attention to the order in which it's written, so that way you can solve it correctly. Okay, number 4, in the right triangle we have ACE and BD is parallel to AE and BD is perpendicular to EC. This just lets you know that you have 2 overlapping triangles. We're trying to find the length of AE. So what I would recommend is pulling these triangles apart. So my large triangle, I have a length that's unknown and the hypotenuse measurement, the full thing, is 20. Then I have this tiny triangle that's overlapping. I have 3 and 4. And in order to calculate this length, I would do Pythagorean theorem or recognize that it is a 3, 4, 5 triangle. So what I've done here is I have a large triangle. Okay, I have a large triangle, which I've drawn here. I would recommend pulling them apart. And we haven't necessarily solved problems involving similar figures, but this is what you would do with it. You would just pull them apart and then set up a proportion. So proportion setup is all about how the problem is positioned and drawn. So these are all turned the same way. So the 20 corresponds to the hypotenuse on the first, or on the 5, on the little triangle. And x corresponds to 3. So the way that you would set up your ratio is 20 over 5 equals x over 3. And now you have a proportion and something that you can solve for x. So to cross multiply, 20 times 3 is 60, and that equals 5x. And when I divide by 5, my x value is 12, which means that the measurement of AE is 12. Now in these problems, you actually don't use the 4 because it doesn't correspond to anything. So there is a little bit of extra information in that problem. All right, number 5. In the figure below where triangle ABC is similar to triangle KLM, what is the perimeter of ABC? So in this problem, what I would recommend is first matching your angles, and we will talk more about this on page 3, which is the next page of notes. But we're going to basically do this problem exactly like we did number 4. So what I'm doing is I'm matching my angles up, so angle B goes with L, and this just helps you make sure that you are matching your angles correctly and you are properly setting up the problem. So this is B, or C and M. Okay? We're trying to find the perimeter of the small triangle, which means we need to find this length and this length. So we are going to do the exact same thing that we did on problem number 4. The 12 corresponds to x. Notice how it's between yellow, blue, yellow, blue. So our first fraction is 12.5 over x. In order to solve it, we don't want to incorporate y, which means we're going to leave 15 out of it. Then we have 7.5, and it corresponds to 3. So our next fraction is 7.5 over 3. By cross multiplying, because remember, these are proportions, and to solve a proportion, you cross multiply, you get an x value of 5, which means this measure is 5. Okay, next we're going to do the exact same thing, but this time we're going to solve for y. So I'm going to go ahead and pick a different color. Let's see here. I think orange will work. I'm going to keep the 7.5 with the 3. So I'm going to just trace this again. I'm going to keep 7.5 with 3 because in order to do these problems, we do need to keep one fraction that's the same. Now you could use 12.5 over 5. It doesn't matter. But now we're going to match 15 over to y. So this now becomes 15 over y. Cross multiply, so 7.5y equals 45. So my y value is 6. In order to get the perimeter of triangle ABC, what you have to do is add all the sides together. So I get 5 plus 3 plus 6 for an answer of 14 centimeters, which is option B. Remember, perimeter means that you add all sides together. All right, number 6. In the figure below, we have this polygon, or this hexagon ABCDEF, and it tells you that the angle of BCD is 42. What is the ratio of angle BCD to the sum of the interior? So this, again, takes it back to geometry. To find the sum of the interior angles, we use the formula n minus 2 times 180. So n, there are 6 sides, so this becomes 6 minus 2 times 180 for a total of 720 degrees. So remember, to find the sum of the interior, you use n minus 2 times 180, which is geometry. Now, it is telling you that it wants the ratio of the angle BCD, which is 72. Okay? So we're going to put 72 first because it is listed first. Okay? And that wants to equal the sum of the interior angles. So the total number of degrees in this shape is 720. So what's happening here is we want a single angle and we want to compare it. Sorry, I keep using equal signs. We want to compare it to the total. So the total degree of this shape is here. So the sum of the interior angles, we solved here to get 720. Okay. So 720 goes here. And then to simplify 72 to 720, you can put it as a fraction if you would like. So 72 over 720 reduces to 1/10. And then to change that to a ratio, the numerator is first, the denominator is always written second. So even if you don't know how to simplify it, like if you can't look at that and go, it's 1 to 10, you can always just set it up like a fraction. And number 7, I think number 7 is the trickiest problem. So it says in the triangle below, side X is 3/5 of side Z. So side X is equal to 3/5, and in math, the term of means multiply. So 3/5 of side Z. So that is how, so I'm going to steal that from here. That's how I got this piece. Then it says side Y is 4/3 of side X. So Y is 4/3 of X. The term of means multiply. Then it wants to know what is the ratio of Y to Z. So I'm going to start up here, Y to Z. Well, we don't really have any connection other than the fact that Y is equal to 4/3 X. So I do know that piece. Well, what do we know about X? Well, we know that X is 3/5 of Z. So what is going to happen is we are actually going to substitute in for X 3/5 Z. Now you have congruent, or not congruent, I'm sorry, the same values on each side. So all we did here was we knew that Y equaled 4/3 X. Like that was told to us right here in the problem. So I replaced Y with 4/3 X. Okay. Then in the problem, it said, well, side X is 3/5 of Z. So where we saw X, we replaced right here. So we took this X value and subbed it in right here. Now we have variables that are both Z. So now to simplify, 4 times 3 is 12 over 15Z, Z. Now what I'm going to do is write it as a fraction to simplify. So I'm going to do 12, 15 times Z, all over basically 1Z. Notice how we have a Z in the top and the bottom of the fraction, which means they will cancel. And then in my calculator, I'm going to simplify 12 over 15 divided by 1. So 12 over 15 divided by 1 gives me a decimal. Math, enter, enter, gives me a fraction of 4/5. However, remember the original values, all my answers are written as colons. So the 4/5 actually changes to 4:5, which is option C. So this problem is very tricky because it involves a double substitution and making sure that you draw on your picture. So drawing on your picture is the best way to properly do these problems. The picture is there for a reason, and it's there for you to use and write on.